Hey everyone, welcome back to the channel. If you are a beginner for Ansys Fluent, then please go through previous two tutorials. The link is in the description. So today we will see how to simulate a lumped capacity model in Ansys Fluent. We will do this step by step. So first we will define the problem. Here is the problem statement. The rectangular cuboid is there, and in which a three-dimensional heat transfer is taking place. The cuboid is at 500 Kelvin temperature initially. It is made of aluminum. The objective is to determine the temperature distribution in the cuboid and changes in it with respect to time. The properties of aluminum is taken as density is given, specific heat is given, thermal conductivity is given. Then we will go through boundary condition and governing equation. So the boundary conditions, for boundary condition, air temperature, surrounding air temperature is given, which is at 300 Kelvin, and convective heat transfer coefficient is given. It is constant for all sides of the cuboid, which is 30 watt per meter square Kelvin, and initial condition, of course, it is maintained at 500 Kelvin temperature initially. For governing equation, this is the final governing equation. In that, T is the temperature at the small t time, and this T is in seconds. T infinity is temperature of the surrounding. T initial is the initial temperature of the component of body. H is convective heat transfer coefficient. A is surface area. Rho is the density of the component. V is the volume of the component. Cp is specific heat of the component. So now we will go for geometry creation. So for that you have to open workbench. In that, go for Fluid Flow Fluent. Name it as a lumped capacity model. Go to geometry. In geometry, here the thickness is negligible, so we will ignore the thickness. We will analyze for 2D case only, which is a 5 meter by 5 meter side. And as you know, in lumped capacity model, the temperature of the whole body remains nearly same, so it will not affect the final results. And because heat transfer coefficient, convective heat transfer coefficient, that is also constant for all the edges, so it doesn't matter if slight thickness is there. Okay, so in geometry we will create a 2D sketch as usual. Click on this Z axis, then XY plane, then go to sketching, rectangle. We will create one rectangle, then go to dimensions, horizontal and vertical. Select two edges and just drop it over here, then give dimensions 5 meter by 5 meter. Okay, then go to modeling, concept, surface from sketches, select the sketch one and apply. Click on generate. So the surface is now created. Okay, so now we are done for geometry part. Then we will go for meshing. Okay, click on z-axis, meshing, mesh, right click on mesh, insert, sizing, then select all 4 edges. This I have explained in previous tutorials, so I will not go in detail. You have to give bias factor over here. Okay, bias on both sides you have to give. Okay, then I will select this one. Bias factor I will give 10, and I will take number of divisions, suppose 100. Okay, and update. If you get unstructured mesh here, then you will have to add one more option, which I will show you. Okay, so the mesh, as you can see, that it is unstructured. So I will go to insert and just click on map face meshing, and I will select the face, apply, and update. Okay, so now as you can see, a structure mesh has been generated and it is fine near the wall. Near the wall where interaction between this aluminum cuboid and air is taking place. Okay, now you have to name all the sides. Here the temperature of all the sides are equal initially, and afterwards also it will remain equal, because convective heat transfer coefficient is constant on all 4 sides. So I will just select all 4 sides and I will name it as sides, because whatever name you give here, you have to give boundary condition to that name, and since the boundary condition for all sides are same, I will give one name only for all 4 sides. Now close meshing, then meshing part, after that we have to do setup. So okay, so mesh hasn't been updated yet, so I will just right click on mesh and update it. Okay, when you see right click over here, go to setup. Here you can select double precision if you want, and we will go for serial processing here. Okay, scale, you can change the unit here. If you change it to mm, then x max will become 5000 mm. So the value will not change, only the unit will change. Close, check, you can check your case here. Report quality, orthogonal quality should be nearer to 1, and it is 1 here, and display, no need to go there. And we are doing a transient analysis. The temperature will change with respect to time here, so I will select transient. Model, we have to turn on the energy equation, because we are dealing with the temperature here. Here we don't have to go for fluid materials, we just have to take a solid materials, and the cuboid material was aluminum. Okay, cuboid was made of aluminum, so I will not change anything here. Okay, properties are given, right? 2719.871.202.4, so that we have to give here. Okay, same properties, then we don't have to change anything here. Then close it. Cell zone condition, here it should be solid and the material should be aluminum. Then okay, boundary conditions, we don't Okay, for sides we have to give boundary conditions. In sides we have to give convective boundary condition with heat transfer coefficient, convective heat transfer coefficient 30 and temperature 300 Kelvin initially. So 300 Kelvin and 30. Okay, we don't need to we don't have to change anything here. Solution methods we don't have to change. Solution control monitors. Okay, for initialization we have to give the initial temperature value, which was 500 Kelvin. Initial temperature of the cuboid was 500 Kelvin, and click on initialize. Okay, I think initialization has been done. You can verify it by from here. Okay, so everywhere it is 500 Kelvin, everywhere, as you can see here. Don't see the color here, just see the values, all are 500 Kelvin. Okay, then we will go for calculation. In that time stepping method fix time step size. We have to take a time step size in such a way that the solution does not diverge. Here I will take 0.01 second. Okay, then I have already done this problem previously, and I have extracted the temperature for 200 seconds. So for 200 seconds and the time step size of a 0.01, you need 200 by 0.01, so 20,000 number of time steps. Then you have to go for calculate. Okay, I can give 0.1 second here, so I will initialize it once again. And I will give 0.1 second here, so number of time step will be 200 divided by 0.1, 2000. Then calculate. Okay, for 200 second it was taking too much time, so I will demonstrate the temperature distribution for 43 seconds. I will demonstrate it for 43 seconds. Go to contours, temperature contour, static temperature display, click on field and display. So as you can see, after 43 seconds the temperature is still nearer to 500 Kelvin inside the body. And if you want to extract this temperature distribution, then you have to create one line from here, from this point to this point over here. So we will create one line. The x coordinate of this point over here will be 0, and y coordinate will be 2.5. x1 coordinate for this point, x coordinate will be 5 and y coordinate will be 2.5. And we will go to plots here, setup. For line 2 we will draw temperature, static temperature. Now as you can see, since it has been 43 seconds only, the temperature near the edges that has started to drop, but the temperature within the cuboid itself is nearer to 500 Kelvin itself. And if you want to extract this data, then you have to click on write to file, write, temperature at 43 second, 43.3 to be exact. Okay, then just open Excel. Select all files here, temperature, and here you don't have to do anything, just go next, 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 finish. Okay, now you have all the values here. Now you can plot by simply inserting a scatter plot. Go to select data, edit at 43.3 second. Okay, edit x values. On the x-axis we want distance, and on y-axis we want temperature. So now the plot has been generated, and okay, this we don't need. Okay. As usual, you can edit this. You can remove marker, and for line you can take different colors. Okay. Now same way, here I have extracted for t equal to 200 second. This blue line is for t equal to 200 second, and same way for t equal to 400 second you have to run it once again. Suppose I have taken for 43.3 second. Now I want it at 50 second, then once again I will run it. So I will wait until it becomes 50 second. Okay, let's stop at 47.1 second. 47.1 second, then once again I will extract the temperature values. Same way for line 2. Okay, not contours, plot, setup, line 2, and I will write that file and I will open it in Excel over here, and I will add another data series. I will add another data series with series name of 45 second. Okay, and x-axis values will remain same, and y-axis values, suppose I am getting the same values, since the temperature difference, time difference is not that much, 43 second and 45 second, so the temperature might not vary. So suppose I am getting the same values, then we will see two plots coinciding with each other. Same way I have extracted for 4 values: 200 second, 400 second, 600 second and 800 second. So that was the post processing part, and I will show you one more interesting thing here. For Excel, suppose you want this value, this value, then this value, then this value, means alternatively you want values on the plot, then you have to discard these alternate values, right? So for that one trick is there. You have to delete these things, then just give 0 and 1 here, then equal to this value. Okay, then go to data, filter. Okay. Select C and filter, then go to filter and click 0 only. So now as you can see, all 1 values has gone, and the remaining 0 values are only here. Here you can see 1 and 3 direct, and 5 and 7, and according to that plot has also been changed. Okay, that's it for today. If you like this video, then please subscribe and stay tuned for the next video. Catch you later.